YouTube? Tired Metalhead Weatherman here. Hopefully you guys are doing well. I've been trying to work on this video for a little while here. It's been a long time coming. I promised this video a while back. It wasn't going to be immediate. It was going to take time, especially with the active pattern that was going on at the time of this video. But yeah, I had been talking about doing videos talking about tutorials on the severe weather systems, reading forecast models, etc. And the condition was that we would get a video up to 10 or more likes. You guys have gotten several videos up to that now, so of course I have to now keep my end of the bargain. One thing that's kind of slowed me down with this playlist is the fact that I was trying to figure out what to start out with. So I actually left it to you guys. I made a post that had a poll on there, and there was a little bit of a voter reaction. Not much. There's only 3. I was hoping for a few more of you to vote, but it's okay either way. But you guys decided that you wanted to see how you can point out severe weather potential on forecast models. So I started looking into making this video, and then I realized there's a lot to this. So I'm actually gonna break this down into several different videos to try to make this a little bit easier to watch. I know you guys don't want to watch a 2-hour long video on how this process works, and honestly, it could be even longer than that in total. But all in all, there's multiple things to take into account when you're looking at forecast models for severe weather. So this will be interesting. This will be an interesting video for, or really, this will probably be its own playlist in its own right. But this will be good for any upstart weather nerds in particular, or just people that are trying to learn something new. So that being said, this video today, we're going to be talking about the jet stream and different types of low pressure. More so the jet stream than anything else, because that's pretty much the key to everything. So let's go ahead and look at this diagram here. And there's 2 jet streams, and they occur in both hemispheres here. The one that's close to the poles is called the polar jet stream, something a lot of us in the US are very familiar with and probably dealing with right now. And then we have the subtropical jet, which tends to be more active in the US around the spring. But these 2 jet streams are active around the world at different points. You can have more activity towards India, maybe around times like September and October, and then around the U.S. that polar jet will start to sink its way to the south. These jet streams move around, and this is how we end up getting a lot of the weather that we get. It's almost always going to have something to do with one of these 2 jet streams. So the polar jet stream in the northern hemisphere is to the North Pole, and then the subtropical jet closer to the equator is going to be towards the south. And this flip-flops when we get to the southern hemisphere, whereas the northern jet stream is going to be the subtropical jet, and the southern one will actually be the polar jet. And really why this is important is because these jet streams will move around, and because of their movement, they will get ridges and troughs. And I can point out what these are to you right now. If you look at my cursor here, what we're looking at right here is a trough. It's a little dip in the jet stream. And usually whenever you hear your local news reporter or the Weather Channel talk about a dip in the jet stream, this is usually going to be associated with a low pressure. And a low pressure system almost always is going to cause inclement weather of some kind. So that being said, whenever you see a dip in the jet stream or a trough develop, that's when you start thinking, okay, this is going to be a more active time for the weather here. When you see a ridge, however, which is this little crest right here, that's usually associated with high pressure. The higher the pressure, either the weaker the storm is, or actually what will end up happening is you'll get very fair weather. Be very calm. So if you see an area of high pressure, it's like, okay, the weather's going to be nice for this day or this week or so on and so forth, depending on how the jet. This all will depend on how the jet stream moves, and this is the case for both hemispheres. So, to anyone that may be watching on the southern hemisphere, because I've noticed a few of you watch from different parts of the world, which is really cool. But just know, whichever part of the world you're in, this rule applies to you too. It doesn't matter the hemisphere. That being said, another important aspect of trying to cover potential severe weather events, snowstorms, etc., is understanding the tilting of a jet stream. And the best way to kind of talk about how this works is actually going back to a little bit of a math lesson here. I'm not going to ask you to get your pencils or Cornell notes or anything like that. Don't worry. But you have to understand the slopes, the types of slopes that you get. The best way to look at this is through a line graph. Now, two of the most important slopes to remember as far as weather is concerned is a positive slope and a negative slope, or positive tilt and negative tilt. It's these tilts that are key to understanding what will happen with potential severe weather events, especially this one, negative tilt. But we do need to know what a positive tilt is as well, because they can end up meaning something in its own, something entirely different, and have an impact in its own right. All right. Okay. So I got a whole bunch of stuff popping up on my screen, and I'm trying to get it off here. But anyway, so there is a positive tilt, there's a negative tilt, and there's also one that's a little less talked about here. That's a neutral tilt. This right here that's highlighted in the with the dark circle in the north to south line here, that is a neutral tilt jet stream. Neutral tilt jet streams are very intricate, because even in that neutral tilt, sometimes you can get little areas where we're kind of leaning towards more of that positive and negative tilt. So you always have to watch these extra close, because you don't know what you can get out of them. It becomes a nowcast type event. But to put in perspective for you, like I said, a neutral tilt, for example, goes from a north to south direction here, and they're usually pretty progressive here. And depending on how things go with that, if these tend to be a little bit more zonal, you could have an increased severe weather threat. So if it's zonal, like say if the jet stream doesn't have a super deep dip into it, or a super deep trough, or it's a little bit more elongated, it's not going to move as quickly, and it can draw in more moisture and other parameters needed to cause a big severe weather outbreak. We'll go over those parameters in probably the next part or two in this video series here. So a good example is right around here. Right around here, actually, they mention it in this page. That right around here on the eastern half of this neutral tilt trough is where the weather will start to deteriorate. And this doesn't only just apply with severe weather, this can also apply with winter weather as well. In this case, I think we're looking a little bit more towards the summer. But the fact in the matter is, though, whenever we get into the winter like we are, or fall like we are now, and you have cold air funneling in behind it, you can get some snow on the backside of this tilt here, or right up against the tilt itself. And then depending on the jet streams at different levels, that can determine the potential for severe weather, along with other parameters such as moisture, instability, etc. So now that we've talked about the neutral tilt, and we've established that it's something that we need to be watchful of, let's go ahead and go to the let's talk about the positive tilt here. The positive tilt here is pretty common in the US particularly. A positive tilt is a storm system, is a tilt in a jet stream that's pretty progressive. It moves quickly, and as a result, usually doesn't have the same kind of opportunity to produce severe weather. But it can still cause severe weather, but it most likely is going to be a linear mode, and usually a lot more subdued as a result. However, it can also produce extended periods of rainy weather on the eastern half of that axis. Not to mention, it can cause flooding depending on how quick that frontal boundary can move. If it ends up being a stationary front, for example, it can become a very disastrous situation. And then also during the wintertime, th- these uh these positively tilted troughs can actually sneak in little areas of warm air into that cold air mass at different levels of the atmosphere. And do you know what you get with that when you have something like snow falling down at the highest levels of the atmosphere, and then once you get into the mid levels, it's warm. It'll melt back into rain, but then once it gets back to the surface, it freezes. You know what you get with that, right? It's freezing rain. You get sleet. Creates very hazardous conditions. So just because a positively tilted trough has a slightly lower chance of producing significant severe weather or snowstorms or something is does not mean that it cannot be watched or it should be disregarded. Now here's the one that always gets a reaction out of me when we see that negative tilt. When we see this, it's called the negatively tilted trough. Negatively tilted troughs have that orientation of southeast to northwest, like you can kind of see it right here. Here's our low level. Here's our low pressure system, and then we can see it with that little tilt facing this way from northwest to southeast here, and this can cause just about anything. Whenever you hear a meteorologist on your local news station, the weather channel, or you hear someone like me or any other weather YouTuber say negatively tilted trough, pay attention, because simply put, these storm systems are that are associated with negatively tilted troughs are extremely powerful. The best way to really think of it is almost like you would be swinging a bat or swinging a golf club, right? When you look at the backs, when you think of the backswing in particular, right? That's where, as you're going forward, that's where you draw that power. That's exactly what goes on with that negatively tilted trough. So you get a lot of lift, you get a lot of instability, you can get warm air, cold air funneling, it can get just about whatever it wants to pull. Not to mention, it can gather a lot of wind energy, and this is why that system is often responsible for some of the bigger tornado outbreaks that we have seen and will see in the future. The instability alone creates a lot bigger thunderstorms, a lot larger hail, for example, even. So they can even produce tornadoes on the winter side of it as well. Draws in more cold air and can lead to heavier snowfall potential. So those are the main three tilts that we have to worry about when it comes to the jet stream. Now, one other thing that I want to mention here, and the reason I'm mentioning it is partially because this is a pattern that these two patterns are what we are likely to see during the winter at some point. It's zonal flow and cutoff low. The zonal flow is important in its own right. Normally, it causes normally it doesn't really cause a lot of big storms or anything like that. But you'll see later on, especially as I get into the more advanced stuff in regards to looking at severe weather potential, you'll see watching zonal flow is extremely important. So if you think about it here, this is here's our two jet streams, for example, right here. Here's the which is represented in the two arrows, right? Or here's our main jet stream. So these aren't very powerful systems, and they usually are more surface oriented. So you aren't going to get that big instability that you would get from a negatively tilted trough or anything like that. But towards the northern end, you tend to get more cool air, and towards the southern end, you will get more warm air. These air masses aren't super strong. There isn't a big contrast, so you don't often get severe weather. However, the reason I mentioned that zonal flow is important is there's little tiny discrepancies in those tilted trough scenarios, especially the negatively tilted, because those two words that I mentioned, progressive and zonal, are extremely important because this can either elongate a severe weather event or shorten it. So try to remember that phrase there, zonal flow. And then of course last here that we're going to cover on this video is going to be a cutoff low. And the reason I mentioned cutoff low being very important is because this is a very common occurrence during this particular time of year. It's also a little bit more common towards the winter and spring, but fall is when I tend to see these the most. So cutoff low is honestly one of the hardest things to forecast, because why it's called a cutoff low is this low pressure area is actually cut off from the airflow, as you can see here based on this diagram. This cutoff low has gone far away from the jet stream, which is all the way up in Canada. And while these are somewhat rare in most cases, they can produce a little bit of everything, and it's like I said, it's always on the east side that we have to watch this as well. These cutoff lows can be cold core and warm core and produce any kind of weather. Unsettled weather always occurs around the eastern half of it, of course. But the reason why these are so hard to forecast is because whenever we look at our forecast models, they want to put this low back to where this to where the main airflow is, and more often than not, it simply just doesn't happen here. The other thing is, with it digging in its own trough, so to speak, it often can funnel some cold air in on the backside of these, and that's how we often will get some snow here. Especially towards areas like the Great Lakes, this is pretty common. Like a lot of times, some of these areas will start out as rain, and even towards the Northeast too. In fact, this upcoming system is almost like a cutoff. I would actually go as far as to say is that's a cutoff low in a way. So this cutoff low will have warm air out ahead of it, and it'll start out as rain, and then it'll have a little bit of wraparound moisture on the backside of it. Not much, but that wraparound moisture will interact with the cold air that's coming in on the backside of it, and that's how we'll get some snow to pop off in places that sometimes won't see snow normally. Like this is a common setup for snow in the southeast, even towards where I live, for example, in Atlanta. Cutoff low is always something to watch. Now, of course, there are many discrepancies with this, including which stems from the strength of the low pressure, the track, and etc. And we'll get into that in later videos with the playlist. But that's pretty much it. That's pretty much all I got here. The first video of the tutorial is done. There will be plenty more. I'll probably be posting more of these in due time, especially since the weather pattern as of right now seems calm. I will still be doing forecast videos, don't worry, but I just figured I'd at least honor my word and get started on this. But anyways, this has been Tyre, Metalhead Weatherman. I will see you guys in the next video. You guys have a good one.